I'm going to record it. Alrighty. Okay, let me just start. F5. Is everybody able to see the screen?
Yes.
Okay, awesome. So good afternoon, everybody again. Welcome to this conversation. And today we'll be talking about outside air for buildings. And special shout out to Christian Kinder. He was very helpful in aiding me to provide some useful resources. So shout out to Christian. Okay.
Okay.
So today's agenda, I will be discussing a couple of topics. I'm sure everybody's going to be excited. We'll talk about the purpose of the ASHRAE Standard 62.1, the 2019 edition, which is the most updated. Some of the scope associated with Standard 62.1, key updates which are associated to the same standard. And then we will talk about several methods of performing the outside air calculations and also knowing the key definitions which the ASHRAE 62.1 states while performing these calculations so that we have an understanding of what it means. I will also give an example, and this example entails of real-time application and which has a solution towards it using the ventilation rate procedure calculation method for an open office space area. Similarly, I will, after my calculation, after my application, I will talk about other ways to approaching outside air calculations, which will entail certain essential comparative requirements between LEED, ASHRAE 62.1, and Title 24 for the California Building Code. And lastly, I'll be more than happy to share my research findings and my citations and my researches in my bibliography. Okay, so all right, so a little bit about the standard 62.1. It was published in 1973, and the purpose of the standard is and was to specify minimum ventilation rates and measures intended to provide indoor air quality acceptable to human occupants and minimize health effects. So this is also intended for new and existing buildings. This particular standard, ASHRAE 62.1, has undergone several updates, and these updates have only been beneficial in order to aid better indoor air quality um, for the times to come. Okay. So some of the scope for the ASHRAE 62.1 is that this standard applies to spaces intended for human occupancy with buildings except within those residential occupancy in which occupants are staying for a long period of time. So essentially we are looking at commercial buildings where this is widely used, and it does have specific requirements when it comes for ventilation, air cleaning design, installation, commissioning. So it has certain parameters set for these requirements as well. In addition to ventilation, there's a whole table which demonstrates the importance of certain contaminants and sources which are often found in buildings. We can talk about nitrogen oxide, carbon monoxide, asbestos, lead, VOCs, tobacco smoke. So it has certain ppm, parts per million, information with regards to each of these contaminants which can cause issues to the people, the occupants. And these issues which generally occurs to the occupancy is like low in work productivity. That's one of the big issue when it comes to contaminants. It also one of the issues other is that it can cause respiratory illnesses, a lot of tuberculosis, and then certain other respiratory illnesses have occurred in buildings, and that is the reason why a regular maintenance check needs to be done. And in other words, what I like to talk about whenever it comes to indoor air quality, just imagine that the buildings are your lungs, and as you breathe in, you want to breathe in clean air, and then that clean air needs to entail what we have HVAC systems doing for us in order to maintain good air quality. But it does not prescribe ventilation requirements for space smoking rooms, patient care areas, and laboratories with hazardous materials. There's a separate standard for hazardous materials and laboratories, which entails more specific information. So ASHE 62.1 does not help us with that information. Okay. All right. So some of the key updates when we talk about 62.1 is that there are new tables for ventilation rate areas for checking new and existing buildings. And I'm going to show you when I'm going to be discussing my application problem, you'll be seeing the table 6.1 and 6.2. It has a more simplified version of the ventilation rate procedure, so, which entails, okay, for particular occupancy type, there would be an RA value, which is your outdoor airflow rates. It will have a it will have an RP value, which would be the outdoor airflow rate per person. So it's very concisely designed and tabulated in a way that we can use that information towards our application. If it's an office or a laboratory or an elementary school, whatever you have. Um, New requirements that natural ventilation considers the quality of outdoor air and interaction of outdoor air with mechanically cool spaces. The humidity control requirements now expressed as a dew point instead of relative humidity. Specification to dew point has been derived in this standard and the requirements of it. It also entails the compliance part that gives credit for particle filtration and also distinguishing between balanced and unbalanced ventilation system interactions and natural ventilation. So this compliance part for credit is also very essential when we come down when I'm going to be talking about lead requirements. And within lead requirements, it has certain credits for specific particle filtration, which actually got derived from this standard. Okay. Okay. So as you may already know, that there are four essential ways of performing the outside air calculations. For this particular session, I'm going to be thriving upon the ventilation rate procedure. And why would I be doing that? Because A, it's a prescriptive design procedure. It is the most well sought out way of finding and the most one of the most simpler way of finding out how much outdoor air do you require in that particular space. And it some of the parameters which are not very difficult for us to calculate and to provide to that calculation would be what is your space type, what how many occupancy levels it is, what is the zone floor area. So it does not make you are not trying to do a lot of research to find to fulfill these parameters in order to get your outdoor air rate. However, when we talk about indoor air quality procedure, it is more of a performance based procedure. There are certain software calculations and there are certain analysis for contaminant sources, concentration limits of perceived indoor air acceptability, and that shall be permitted to be used for any zone or system. And this particular indoor air quality, it has certain tabulations where it has information for each and specific air pollutant, and that air pollutant it will have that information associated under the indoor air quality procedure. And there's a lot of as it's a performance based procedure, there is certain softwares which helps us find out the this method. Okay, natural ventilation procedure. So again, this is a prescriptive design procedure. It's a lot more simpler than the VRP procedure because for this, it's a because the outside air provided through the openings and through doors, and it shall be also used for any zone for mechanical ventilation system. And um, for any mechanical ventilation system, it has more requirements than a natural ventilation system, which I'll talk about now. And lastly, about outdoor air treatment. Each ventilation system provides outdoor air shall comply with the section 6.1.4 and 6.1.42, and the particulate matter must be smaller than 10 micrometers to 2.5 micrometers. And in the table 6.4, you will see that as we proceed. So any comments, anything which you like to bounce off, any questions anybody has before I move forward?
I'm good.
Okay. Okay, sounds good. Move forward. Alrighty. So important definitions, as I emphasize the importance of knowing what exactly what means. So breathing zone outdoor airflow, which I'm going to be emphasizing today about. The outdoor airflow required in the breathing zone, which is VBZ, of the occupiable space or space in the ventilation door shall not be less than the value determined according to this. What is this trying to tell us? Like when we need to know the breathing zone outdoor airflow, it does not only involve the building components, which it could be your systems, your systems which you put in your buildings, your electronics, your gadgets, whatever, but it also entails the people component and how many, what's the occupancy, what are they doing at a particular time of the day, and that complete information is needed in order to determine the breathing zone. And breaking it down, this formula, it basically tells me that when we talk about the zone population, this zone population you would need to provide, and that population, if and I'm going to be telling you why it's needed in the next slide. Similarly, the RA values, which is your minimum CFM per square feet, and the RP values are also RP values, which is the minimum CFM per person. They are also these are constants which you're going to find in the table 6.1, so that we would not have to worry, and it's particularly focused towards what kind of occupancy description is it, if it's a laboratory or a computer lab or it's a classroom. So we will just need to find it into that table. And finally, the zone floor area, that this is an easy one. So depending on whatever your floor type is, you can I would usually use AutoCAD. If I don't have cut sheets or anything, I would use an AutoCAD software to just determine what's the area, and then determining the square footage of the area. That would be the one which I would plug into this formula in order to get to know my breathing zone. Okay. Okay. Alrighty. So talking about this table, the minimum ventilation rates in the breathing zone. Let's, as you're understanding here, that it has an occupancy category, art classrooms, computer lab, and we, the way I highlighted in the computer lab states that, we are seeing a 10 CFM per person of people outdoor air rate, which is RP, and then 0.12, which is the area outdoor air rate. And then there's a default values. And these default values essentially means that if you don't know, if you're not sure of what is the population of that particular area, then these are ASHRAE has derived certain default values which you can plug it from. So in this case, it is 25 per 1,000 square feet, or it could be 25 per 100 meters square. Okay. Okay. And please feel free to interrupt me if you want to understand something. If you have any questions, I'll be more than happy to discuss more about it. All right. So talking about an application, now I'm going into an application standpoint of thing, and let's talk about a 20 people in a computer lab, which is in 30 by 30 square feet, which is 900 square feet. And you want to find out and calculate the outdoor airflow rate to the breathing zone using the table 6.1 derived from the outside air calculation, outside air requirements. Okay, so again, I need, if you're looking at the slide, the numbers indicated in pink are the numbers which have been derived from the table 6.2.2.1, and the numbers in black are essentially the variables which our problem has, which is a 20 people in a computer lab and the area which is 900. And simply when you just put it together and summarize it, you're getting a 308 CFM of ventilated airspace, and that is what is again your breathing zone outdoor airflow. But again, if we did not know the occupancy, in this case, we knew the occupancy, which was 20 people in a computer lab. Now, if we did not know, then we use our default values, which if you carefully look into the default values column under the computer lab, it says 25 per 1,000 square feet. And that's what you'll do. You'll do 25 per 1,000 square feet times the area, which is 900, times CFM plus 15 CFM per square feet, which is your default value out here. So that will again help you determine your CFM requirements. Note that what you're seeing as a 308 CFM and 338 CFM, there is a small difference. And however small it is, that is a difference. And that needs to be taken into account. And what that means to me is that if you know the number of people in a computer lab, and if you're a designer, that is what you should be going based out of. And if you do not know in any circumstances, then then using the default values is just a buffer, and that's not a bad idea as well. Okay, coming down to the second part, which is determining your zone air distribution effectiveness, which is your EZ value. And this is again in the table 6.2 within the manual. And EZ is basically your measure of how many effectively the zone air distribution uses the supply air to maintain acceptable air quality for an occupied zone. So let me quickly move in to explain you that the cool air is nothing but the air cooler than the space temperature, and the warm air is the air warmer than the space temperature. So that needs to be 100% understood. Okay. So when you want to calculate the outdoor airflow, which is your VOZ, which I just talked about, the formula again, it tells us that it is the breathing zone outdoor airflow divided by the effectiveness. And as in our previous slides, we calculated the breathing zone outdoor airflow, which is 308 CFM. When we are talking specifically for a cooling mode, when you want to provide cooling to that particular space in this computer lab, then it's going to be, you'll be needing 308 CFM outdoor air, and you're going to divide that out by 1.0. And 1.0, essentially, we got it from here, which is your ceiling supply of cool air, which is 1. And in the heating mode, it's rather more interesting that I found out that 385 CFM outdoor air must be delivered. And then this 385 CFM essentially came from zero point zero 0.08, a zero point 0.8 of the ceiling supply of warm air 15 degrees Fahrenheit or more above the space temperature. And if we look into the heat transfer or thermodynamic aspects of this, what does that even mean to us? Why are we needing less CFM for a cooling mode as opposed to a heating mode? Well, it's as from a grill, it's just a common understanding that how cool air is more dense than the hot air, and because of the density, you are having these values, and it requires a lot more work to provide heating to a space than providing cooling to a space. And ASHRAE has been able to, sorry, let me go back. ASHRAE has been able to provide you this information through this air distribution configuration table. Okay. All right. Any questions, anybody, before I proceed to the next slide?
No questions.
Okay, wonderful. All right. So the ways to approach outside air calculations. And over here, I will be talking about Title 24 ASHRAE LEED version 4.1 requirements and how are they in sync with each other, and some of the differences which lies, and I'm going to be doing a little bit of a comparative study of their requirements with each other, knowing that both of them go based out of ASHRAE 62.1. All right. So some of the considerations which we will be talking about and which is being considered for each one is Title 24 has information and considerations about space and occupancy essentially. Whereas in ASHRAE 62.1, we just talked about the VRP ventilation rate procedure. We needed to understand what is the diversity of the occupants. How many occupants are there? What kind of space is it? You also want to know if you have an HVAC system, what is the efficiency? And that itself helps us to determine the requirements for ASHRAE 62.1. Whereas in LEED version 4.1, essentially LEED is a credit-based system, right? And based on 62.1, it is essentially the tables which we saw right now, table 6.1, table 6.2. They are exactly the same in LEED, in the LEED requirements in the LEED handbook when it comes to indoor air quality. And but however, the rules are more stringent, and a credit specific credits are being given for specific requirements which they have updates on, which I will talk about. And similarly, when we talk about software, trace train is what we use essentially for our work right now. And within trace also, it talks, it's essentially imbibing its information from ASHRAE 62.1. I did wanted to talk about how to go about, you know, plugging your information in train. What are the what is exactly you might want to know before putting down the values when you uh, in the values in train. But for this presentation, I wanted to make it more simplified and concise with regards to our goal, which is knowing the essentials of ASHRAE 62.1 and the key updates about the Title 24 and LEAD. So I'm more than happy to discuss train specifically in our next presentation coming. Okay, so for Title 24 requirements, specifically talking about mechanical ventilation right now. So these NFS require that a mechanical ventilation system provide outdoor air equal or exceeding the ventilation rates required for each of the spaces that it serves. And again, this is again from our, this statement is exactly, I saw this statement exactly in the handbook of ASHRAE 62.1, so nothing really changed here. Some of the required minimum ventilation airflow at the space can be provided by an equal quantity of supply or transfer air. And at the air handling unit, the minimum outside air must be the sum of ventilation requirements for each of the space that it serves. So again, you can also, you know, let's do a visualization right now. And in this visualization, I would just like you to visualize that you have an air handling unit and it's serving different zones, and with different zones, in order to understand the total outside air requirement for that system, for that air handling, you would want to calculate that VBZ value for that each occupancy zone which you have. So if it is a building which has, conference rooms, it has a movie theater, it has it has a laboratory, it has a music room, then you would want to make sure that you have the VBZ value, which is the breathing zone outdoor airflow value for each of those zones, so that that would help you determine the total sum of the ventilation requirements for the space that it serves from the air handling unit. That's the meaning. And for each space requiring mechanical ventilation, the ventilation rates must be greater of either the conditioned floor area of the space multiplied by the outdoor area rate, which is in the table 412. And this provides a dilution for the building borne contaminants, like if there is glassing off of paints, carpets, furniture, certain VOCs, molds. And that is again, which I talked about in the 62.1. Why is it important to have at least that minimum outdoor air, so that you want to make sure that the lungs of that building are healthy. All right. So in the second aspect, the space designed for an expected number of occupants or the space within the fixed seating. The outdoor airflow rate to the zone must be 15 CFM per person multiplied by expected number of occupants. And for the space with a fixed seating, which is a theater auditorium, the expected number of occupants is the number of fixed seats as determined by the California Building Code. So this is also a great way of us to determine what would be the zone population, which is your PZ value. And if you have, auditorium, theater, conference room, a certain laboratory, which has already, if we have an architectural drawing, which indicates the furniture plan, of how many seating is there, what kind of equipment is there, then it becomes, for a designer, it becomes rather simpler to estimate the value of what would be the PZ value, and also the outdoor airflow rate, which it says that it needs to be 15 CFM per person based on the code requirements. Okay. Alrighty. So talking about the big two, and these big two is essentially, as I already told you, that ASHRAE 62.1 is the bedrock. But now, what is the difference between Title 24 and 62.1? Why is Title 24 a little bit different than 62.1? And let's talk about it right now. So in the table 120.1, within the minimum ventilation rates, if you go on the Title 24 website, you shall see this table, which indicates your RA value, your minimum air rate for demand control ventilation, your air class, your notes, and doing a comparative of seeing how office space for an RA value is 0.15. However, for an office space for an ASHRAE 62.1 in the table 6.1, why does it tell me that it has a lower RA value of 0.06? So that is something which I noticed, which is a discrepancy, and I wanted to put this out here for you guys to understand that there's a difference in the information. So Title 24 has a higher RA value, which is RA value is again the outdoor airflow rate per unit area, and ASHRAE has a lower RA value. ASHRAE also does not have any minimum air rate for demand control ventilation in this table. However, Title 24 recommends that you need to have a minimum air for demand control ventilation. And in the demand control ventilation column, this column basically specifies minimum CFM per square feet that shall be used to comply within this section, which is 120.A, and this needs to be performed. Okay. Okay. Now coming down to LEED requirements. Some of the LEED requirements, which I'm sure you must be familiar of, and this is specifically with regards to the LEED version 4.1, according to USGBC. And I'm going to be talking about the mechanical ventilated spaces. So for the mechanical ventilated spaces, this must be designed under the ventilation rate procedure method or any applicable code which is more stringent. So from this statement, I have understood that even LEED has an understanding that the ventilation rate procedure is something which is more easily, and there is it's more simple to actually for a designer to put in the values and get what you require, as opposed to an IAQ procedure or any other procedure. So that itself tells me that even LEED is interested in VRP. Some of the key updates with regards to this, I'm going to be talking about the prerequisites, and then the 2 credits, and then 1 credit as per the key updates. Talking about the prerequisite 1, which is not a credit, okay, please note, and the environmental quality, which is the EQ, requires compliances to all relevant sections of standard 62.1 and not just ventilation rate procedure rate section. Similarly, one of the key update is for getting a credit is that the increase in breathing zone outdoor air ventilation rates to all occupied spaces must be at least 30% above the minimum rates required by ASHRAE. So this is a really important difference, which I noticed, is that ASHRAE 62.1 is 30, that LEED is trying to make sure that we're not just maintaining the basic requirement of the standard, but we are actually going above and beyond the prescribed basic requirement offered by 62.1 ASHRAE. And once you go above and beyond, LEED recognizes as a score of credit, 2 credit with regards to your project. Similarly, talking about requirement for carbon dioxide sensing to monitor ventilation system performance in densely occupied spaces. That is a requirement. You need to have a CO2 sensor to monitor ventilation. As it does not specifically tell you to where to place the CO2 sensor. And often it is not a good practice to have a CO2 sensor right in front of the return air grill. That is one of the practices which I understood after I read a couple of articles where you should be placing your CO2 sensors. But as a general note, those with design occupant densities which are greater than or equal to 25 people per thousand square. So the CO2 concentration must be monitored within the space between 3 to 6 feet above the floor. And the outdoor airflow rate measurement devices must be required for mechanical ventilation serving spaces. So wherever you're having mechanical ventilation serving into any space, you need to place a CO2 sensor. And that CO2 sensor should be carefully placed and calibrated on a regular times. And also depending on the manufacturer, um, what is the manufacturer of the CO2 sensor asking you to do? Like, what is their protocol of making sure that the quality is fine, the maintenance is fine? Well, that has been highly recommended under the lead requirement. So testing and calibration is also very important, which I just talked about. The CO2 sensors have to have accuracy of no less than 75 ppm or 5% of the reading, or whichever is greater. And you need to and then if it rises more than 15% than the minimum outside air rate, the alarm should go off, indicating that the CO2 level has risen in that particular zone. So that is a requirement. If it does not generate an alarm, then that is actually you are going against the rule, and that is again can cause threat to the occupants who are in that breathing zone. Okay, so the lead V4 requirements continuing to the naturally ventilated spaces. Before naturally ventilated spaces, I talked about the mechanically ventilated spaces. So naturally ventilated spaces, they have to be again designed according to the ventilation rate procedure. And some of the key updates are essentially same as that of the mechanically ventilated spaces. There is not a lot of updates or dissimilarities with regards to the first one. But the key updates over here is that you need to provide a direct exhaust airflow measurement device capable of measuring the exhaust airflow. And this device must measure the airflow with an accuracy of 10% plus or minus from a design minimum exhaust airflow rate. And then again, the alarm must indicate when it goes above 15% more than the exhaust airflow set point. So again, it indicates over here that you need to make sure that if there is if the exhaust airflow is going above the certain set point with then 15%, that's when the alarm needs to go off to indicate um, what's happening with the exhaust airflow. And similarly, with regards to providing automatic indication devices on all natural ventilation openings is intended to meet the minimum opening requirements. To this point, I would be honest to tell you that with regards to automatic indication devices, um, these I am not very familiar of these indication devices. However, I'll be happy to do my due diligence of doing more research and then provide you what does it really mean by indication devices. I can do that.
So naturally
And
ventilated kind of goes out the window if you have to put an exhaust fan on it. But anyway,
okay,
has anybody on the call deployed anything like this?
No, I've never done
Yeah.
this yet.
I mean, it'd be interesting. You have a whole new class of windows with flow sensors on them. Go ahead. Go ahead. I'm
okay,
just
worries, no problem. Okay, so um, if you want to find out, the outside air calculations again, according to ASHRAE 62.1, they do have an Excel program which helps you determine for every zone how to find out this calculation, and LEED follows the same protocol. So it's not that the LEED requirements is going above. They are going above and beyond because they have their stringent requirements, but they're not really going very much off the format of the Excel calculation as what ASHE 62.1 offers to us. So I wanted to make that clear with everybody that this is not a big difference. Hence, I did not even mention it in this segment. Okay, so towards the end of my presentation, I did talk about several key aspects and key aspects with regards to the scope, definitions, key terms of ASHE 62.1. We did also talk about an example of a computer lab where we found out the zone air effectiveness, which is VZ. We found out the breathing zone outdoor airflow using the ventilation rate procedure calculation for that particular space type, my application example, which I was talking about. We also talked about certain differences and certain comparative study on on a regulation standpoint level with regards to ASHE 62.1, LEED, and Title 24. And finally, we also discussed several key updates with regards to LEED, and these key updates are again the best practices. But again, for any designer, some of these are minimum requirements. So again, going above and beyond these minimum requirements would be beneficial for the intended occupancy. But as I understand and as you understand that, we also have to make sure that we are providing a quality equipment to the client, but also making sure that we are not going to make it too expensive also. So following these requirements is always a plus because it gives us credit, but it also gives us a direction of how to go about in dealing with the subject of indoor air quality. And I'm more than happy to share my research findings, which me and Christian Kinder worked together to find it. Thank you very much.